Hello and welcome back to my channel. Up till now, we've discussed the topics like the basic concepts, like what matter is, how many types of matter is there, and all these things, classifications. Then we discussed about the laws governing it, right? All the chemical combination laws, Avogadro's law, Gay-Lussac's law. Now it's time for us to discuss the real stuff of this chapter, which is atomic mass, molecular mass, and further mole concept. So let's begin with the topic today. The topic that we're going to cover today is atomic mass. It's a very interesting topic and it has a lot of basic concepts involved. So let's begin with atomic mass. Okay, what exactly is atomic mass? See, in simple terms, atomic mass is nothing but it is the mass of an atom. That's it. It is the mass of an atom. Mass of an atom. Now tell me, what do we have in an atom? So in any atom, let it be, let's say, as small as hydrogen. In hydrogen atom, we have one proton in the center, one electron here revolving, and no neutrons. So if I try to find the weight of this hydrogen atom, what would be the weight of this? This, if I try to put it on a pen and try to find the weight will be the mass or weight. In chemistry, they're same. So mass of one atom, please focus. One hydrogen atom will be nothing but mass of proton plus mass of, yes, electron. Okay. Now we happen to know that the mass of electron is 9.1 into 10 to the power minus 31 kilograms. See, mass of proton is 1.667 into 10 to the power minus 24 grams, right? And mass of neutron, however, it is not applicable here, but still we should know it, will be, this is just 667 into 10 to the power minus 24 grams. So mass of neutron is almost, same as mass of proton. We can take them as same, no problem in that. Cool. So I hope you got the idea behind finding the mass and all. So what exactly is mass? Mass is nothing but, mass of an hydrogen atom is nothing but mass of proton plus electron. So let's find it out. Yeah. So how many protons are there in this? One proton. So it will be 1 times 1.66 into 10 to the power minus 24 grams plus 1 times 9.1 into 10 to the power minus 31 kg. I'll make it as 27 grams. Yeah. Now, can we add 10 to the power minus 24 and 10 to the power minus 27? It's like adding 10,000 with 1. Does it make sense? No. Adding 1000 with 1 also doesn't make sense. This is a very small value. I can ignore it. So we can literally ignore the mass of electron every time. So what is the meaning of mass of one hydrogen atom? Atomic mass of hydrogen, which is nothing but number of proton and neutron. But since there's no neutron here, we can say atomic mass of hydrogen is going to be 1.66 into 10 to the power minus 24 grams. Isn't it? Don't you think it's too much to remember? 1.6 into it takes a lot of time, right? 1.6 into 10 minus 24 grams. That's the problem, right? That is why people said that why don't we take this as 1 AMU? Because it is the mass of smallest atom we can have. So let's take it as 1 atomic mass unit. Therefore, that is how the atomic mass of hydrogen is 1 AMU. Nowadays they call it as unified mass. So 1 U, same thing. 1 MU, 1 U is the same thing. And what is 1 U equal to? 1 U is equals to 1.66 into 10 to the power minus 24 grams. Please remember this value. So what is the mass of one hydrogen atom? 1 U, which is nothing but mass of proton. That is why the definition of atom mass number, atomic mass is same as mass number. That's why the definition of mass number is is same as atomic mass, right? Is same as atomic mass, and it is nothing but number of protons plus neutrons. It's not that we don't have electrons. We also have electrons, but we don't take that mass of electron. Why? Because electron is very light. So number of electrons are always ignored. That's why the mass number is nothing but sum of proton plus neutrons. Okay, so let's take another example. Sodium. What will be its mass? Sodium has 11 protons, 11 protons, 11 neutrons, or 12 neutrons, sorry. It has 12 neutrons and 11 electrons. It has 11 protons, 12 neutrons, and 11 electrons. Will I consider the mass of electron? No, not at all. It's zero. Therefore, one more thing. Sometimes back I told you that mass of proton is almost same as mass of neutron. So this is the liberty we can use. I know we can consider them to be same. So P is equal to N. That means 11 plus 12 will be 23. That's why we get the mass of it as 23P or 23N, whatever. What is the mass of proton? U. Yes. See, we just saw that. What is the mass of proton? U. So the mass becomes 23U. So that is how the definition of atomic mass is given. It is the mass of one tiny atom that we have. Right? That's how we find it. This is the concept. Now moving on. Now the question is, what are some common masses that we have to remember? So guys, you must remember hydrogen has a mass of 1U. Please remember these values. Then we have lithium. Lithium has a mass of helium first. Helium has a mass of 4U. Lithium has a mass of 7U. Now, what do you understand from here? We understand that helium is 4 times heavier than hydrogen. Lithium is 7 times heavier than hydrogen, and that's how it goes. Yeah. Then we have, after this the carbon is important. Yeah, 12U, the most stable one. Yeah. Then we have nitrogen, which is 14. Then we have nitrogen, which is 14. And then we have oxygen, which is 16U. See, U is the important unit of atomic mass, unified mass. U. Please remember, it's not gram. Okay, I have seen people getting confused there. Don't get confused. U is basically the unit of atomic mass. Hydrogen, helium, lithium, carbon 12, nitrogen, oxygen. And then we have sodium, important, 23U. And then we have magnesium, 24U. And then we have aluminum, 27U. Then we have phosphorus, 31U. Then we have sulfur, 32U. These are the masses that you should have it at your fingertips. Then we have calcium, 40U. Chlorine, 35.5U. And this is the main problem. How come we got a fractional mass? Even the mass of carbon is 12.008. So how come we are getting fractional mass? That's the question, right? Like, how are you getting fractional mass? Is it possible? How is it even possible? Because if the mass number is sum of proton and neutron, then how can it be fraction? Can we have half electrons? Can you give me 7.5 electrons? Makes no sense, right? Therefore, what we have to say, this case actually is something else, and that is going to be our next topic. So apart from that, there are a few more masses that you must consider remembering, like copper is 63 U, and then iodine is 127U. So the list is huge. As much you can remember, it's fine, but probably they will give this in your exams. The data would be provided in your exams, but these are the common masses that you might consider remembering. Okay, so if possible, remember them. If possible, remember them. Moving on to the next part. The next part is why chlorine has a fractional mass. It's a big question that we are raising. Why chlorine has a fractional mass? Why chlorine has a fractional mass? Of not fractional, decimal. So why chlorine has a fractional or decimal mass? So this can be a question that you may be asked. So let's try to answer this question. The answer to this question is the reason that chlorine has a mass of 35.5 U is because 35.5 U is the average atomic mass of chlorine. It's the average atomic mass of chlorine. Okay, what is that is average? So let's try to understand that. See, suppose you are a geologist and suppose you came to know that under this earth's surface, somewhere down in the earth's surface, there is a place where there are 100 chlorine atoms available. Okay, just take an hypothetical case. 100 chlorine atoms available. So you take it out, you know, and you give it to a chemist, a chemistry person. Now he starts weighing those atoms one by one. And it was surprising that he got 70 atoms, okay, 70 atoms out of 100 atoms with a mass of 35 U. And the rest 30 atoms were 37 U. And he was surprised. How come we have this? So the reason we have different masses is because of presence of isotopes. Because a chlorine atom has two isotopes, chlorine 35 and chlorine 37. That is why there are different masses. Now imagine if you were the chemist person, what you would have informed other people that the mass of chlorine atom is. What would have been the mass of chlorine atom as per you? Is it 37? No. Is it 35? No. Then what is it? Average. So that's when the concept of average comes. So this is what we mean by, finding average mass. So due to the presence of isotopes, masses sometimes becomes fractional. So let me tell you how it can be done. So from now onwards, whenever you get a question, make a table. Okay, make a table like this. On the left hand side of the table, write the isotopes that we have got. Okay. On the right hand side, write their percentage abundance, as in how much of that is available. Like in this case, it was 70%. 70 atoms out of 100 is 70%. 30 atoms of 100 out of 100 is 30%. The isotopes were chlorine 35U, chlorine 37U, right? And the percentage is 70% and this is 30%. Now, what would be the mass average? How to find it? So the formula for finding mass average is always like this: 70 into 35 U, 70 into 35 U plus 30 into 37 U, 30 into 37 U divided by how many atoms are we counting of? 100. It's always 100 as the denominator. So the mass average comes out to be approximately, if you calculate it, it'll come out to be 35.5 U. This is a clear indication that the mass actually was average mass. It's neither the mass of chlorine atom 35 nor 37. It's an average value. So whatever mass you have studied here, right, they are all average mass. Or rather, in most of the cases, they are average masses. So I have answered questions like what an atom, what is atomic mass, how we actually calculate it conceptually. Then I told you some values. Then I told you why some of them have fractional mass. Now, the next topic that we have to do is how to deal with problems, right? How to do questions. So this is the notes. Yeah. Now the thing is, we'll see how to do questions. So for numericals, I'm giving a standard template. You can use it. I'm giving a pattern, like an algorithm. For numericals, again, do the same thing. Draw a table. Okay. And then on the left hand side, yes, isotopes. Very good. On the right hand side, percentage availability. Excellent. Okay. And suppose the isotope is element with a mass A. Another isotope is element with mass B. Another isotope is element with mass C. And their percentages are X%, Y%, Z%. Then what will be the mass average of that element? So mass average of that element will be A into X. That's the algorithm. Whenever you get a question, this is how we do it generally. B into Y plus C into Z divided by X plus Y plus Z. Don't worry, x plus y plus z will always be 100. That's a safe side, you know. So the answer will always be mass average can be calculated by the formula ax by cz by 100. Using this formula, sometimes you may have to use this one also. You can do any numerical. That is how we can find the average mass. And one more concept, then we'll wrap this video up. So there's another concept that we must know, which is the definition of atomic mass. Atomic mass definition. So what is the mass of an atom? What is atomic mass unit actually? And the definition of AMU can be asked sometimes. AMU. What is the definition of AMU? What is AMU? 1U, right? 1U. How can I get 1U? So let's see how we can get it. See, it is defined as the it is defined as 1/12. It is defined as 1/12 the mass of carbon 12 isotopes. It is defined as 1/12 the mass of carbon 12 isotope. Why carbon 12? There are many theories behind it. Probably it was most abundant, that's why people used it, or it's the most common one, that's why people used it. There are many stories behind it. But for us, it doesn't really matter why chlorine, why carbon. It matters how carbon. Like why carbon is chosen, that's not an important thing, but how it is used, that is important. So have a look. How can I get 1U or 1mu on the left hand side? Or how can I get that? If you divide C12, what is C12 mass? It's 12th isotope, right? The mass will be 12U. Yeah. And it is 1/12. So 1 by 12 into 12 will give you 1U. That's it. Simple. It's like holding your nose backwards, by moving your hands down and then holding it. But that's how the definition goes like. I know it's weird, but that's how the definition is given as. Now, is it that we can only define with carbon? Not really. You can also define it using sulfur if you want to. How? You can say it is defined as 1 by, yeah, any guesses? Yeah, 1 by 32 times the mass of S32 isotope. If you like, you can do it like this also. You can add in terms of nitrogen also. You can add in terms of oxygen also. Whatever works for you, you can use it, no problem. But in books, the standard is C12 isotope. That's how AMU is defined. So we have discussed this part. Now in the upcoming session, we'll be doing some numericals from this formula. This one. We'll be doing some numericals from this formula. So let's summarize all the things we discussed. So today we discussed about atomic mass concept. I told you what it is. Then I told you to remember this value. Then I told you that mass of proton is same as mass of neutron almost. Mass number is nothing but proton plus neutron. Then I told you to remember these values if possible. Of course, you should eventually. And then I told you why some elements have fractional masses. It's because of isotopes present. And it's also the average mass. Then I gave a standard formula, a general formula for doing numericals. This is the one. And then I told you about what is the definition of atomic mass unit. So these are the things we discussed today. In the upcoming lecture, we'll be doing some numericals of average mass. So I hope this session was useful. If you're liking this series, please share with your friends so that it can reach to the people who are in need. Thank you so much.